So, what we're going to look at now is one of the, I suppose, most important things really for our coordinate geometry of the line, which is what we call the equation of a line. Okay, so we're used to that idea of an equation, some sort of expression with an equal sign where we have terms on either side, where the value on the left is supposed to kind of equate to be the same as the value on the right. So what we want to look at first of all is kind of how does this apply to a line and understanding that equation of a line. We've looked at coordinate planes, or you're familiar with a coordinate plane having an x and a y part, so any point on the plane has an x coordinate and a y coordinate, and a line is a collection of these points. Okay, so a collection of points that have an x and a y coordinate, and there has to be some sort of relationship between those coordinates for a point to fall on a line. Okay, so if we say, for example, like the left hand side here, if the equation of the line that I have is y equals x plus 4, this means that for every point on the line, the y coordinate is 4 more than the x coordinate. So we can kind of nearly read that, thinking back to kind of our algebra, even from second year, and kind of our word equations, y equals x plus 4, so y is 4 more than x. And that'll be true for every point on the line. And we can see the line's been plotted here. So one of the first points, -4, 0. So if the x is -4, the y is 4 more than that, so 0. -3, 1, -2, 2, -1, 3, and we can kind of see that pattern. 0, 4, I suppose, the most obvious one that follows in there. And the key thing, I suppose, as well, is that every x value will have a y value. If the equation is 2x minus 1, then for every point, the y coordinate is double the x coordinate minus 1 here, obviously not -6, -1. Okay, so we can see the different values that we have there. So say we look at 1, 1, so double it -1, that just gives me 1 for my y value. If my x is 2, double it, I get 4, -1, I get 3. So that matches up with the point I have here. If I have 3, 5, double it, I get 6, take away 1, I get my 5, and it matches up there. So each point we can see on the line does have an x coordinate and a y coordinate, obviously, and they are following a same pattern. Okay, for the points to be on the line, they have to follow that same pattern. I suppose the other things we can look at here is maybe looking briefly at even slope. Say we look at the rise over run idea that we had already. If I go across a distance of 1 here, I need to go up a distance of 2 in order to still stay on the line to find. So my slope here is going to be 2. Same thing again, then if I go over 1 and go up 2, I find my next point on the line. So to find my next point on the line, I might go over 1 to an x coordinate of 4, and I go up 2 to a y coordinate of 7. So I would theorize that maybe 4, 7 would be on the line, and indeed if we do 2 times 4, get 8, take away 1, we get 7. Okay, so we can kind of see how slope also has something to play, has a role to play in this relationship as well. So let's move into then finding the equation of the line. And there are two things we need to find the equation of a line. And this is really, really important. Okay, you should know this straight off. The minute you see equation of a line, you should know that you need to find slope and point. Slope and a point. Okay, these are the two things you need to be able to find the equation of a line. If we look at the formula here in the box, we can see the slope given by m, and then my point obviously represented by my y1 and x1. Okay, we can also see in the formula there is another y and x part, but if we look at the lines that I gave you already, those had y and x within them. So each of our equations of a line should have a y and an x part when it's solved, when it's presented, and we are only going to be substituting in for x1 and y1. So that's kind of the first bullet point that I have here in terms of using the equation of the line formula. The next thing is being careful just for subbing in with those, especially if we have a negative number. We've seen that in some of these other formulas we've been using. And the last thing then is if we're given 2 points instead, we may have to first find the slope and then find the equation of the line. Okay, now underneath the formula here, we do see one type of equation of a line, y equals mx plus c. We're going to talk about that a little bit more in 1 minute, but just to be aware that it is a particular format or way of us to write the equation of a line, and just being kind of ready to kind of use that, I suppose. So let's look at the different types of equation of the line that we have. Then the first one we're going to start with is maybe what we'll call like our general form, ax plus by plus c equals 0. So everything on one side equals to 0, and it's just kind of our general base level form. So the steps in finding the equation here is pick the slope and point. So that's kind of what I said at the start there. That should be coming off straight away for you. You need slope and point. We carefully substitute into the formula and we rearrange it to get this required format that we want here. Okay, the only other parts I might add here is ideally we would like A to be positive. Okay, generally when we write an equation, we like the first coefficient, the first number there, to be positive in our equations. That's just kind of convention nearly, that we would start with a positive number, and just kind of leaves things looking that little bit cleaner, I suppose. So it says find the equation of the line passing through these 2 points in this general form. So the 2 things I need to find the equation of a line are slope and point. I can already say that I'm going to use one of my points that I have here. We might decide to use the point 4 or 5. It makes absolutely no difference if we're to use the point 2 minus 1 either. To find the slope, I need to use my slope formula because I don't have a graph, so using rise over run here doesn't really seem the most optimal for me. So let's label my points x1, y1, and x2, y2. So y2 is 5 minus 1. So just watching out for my negative signs here. And x2 then is 4 minus 2. So that's going to give me 5 plus 1 over 4 minus 2, which is 6 over 2, which is 3. So I have a slope of 3 and I have a point 45. I need to use now my equation of the line formula, which again is in my formula and tables book, but we'll just put a little note here beside it that that's the formula I'm using. I'm going to fill in those relevant pieces of information here. I'm using the point 45, so I'm going to fill in 5 for x1, 4 for y1. You equally could use the 2 minus 1. Multiplying out my bracket here, 3x minus 12. I'm going to bring everything over to the left hand side because it just avoids me changing as many signs. And we'll just adjust. I can swap things there without having to change signs because all I'm doing is changing the order that I'm writing them in terms of the equal sign. I haven't moved things over really. I'm just kind of swapping both of them around. And I get my end result, my equation of the line, written in the format that they requested. Okay, that's really all there is to it in terms of writing the equation of the line, using the information that's given to us and filling it into the formula correctly. I'm going to skip over those examples here to look at our second way of writing the equation of the line, and we're going to call this one slope-intercept form. Okay, and this is just to do with the 2 pieces of information that we can take from this equation. So the first, I suppose, in the name there is slope. So to find the slope of a line from its equation, we look at the coefficient of x here. And there was a reason we highlighted this. We have that letter m, so the number in front of x, the coefficient of x there, is going to represent our slope. And that's always going to be the case when we have our line written in this format of y equals and the rest there. Okay, so m will represent my slope. Then the last point, 0c, will represent the y-intercept, and this is where the line crosses the y-axis. And we'll talk about this a little bit more, but even just to touch on it now, at the y-axis, if we kind of think of our coordinate plane, my y-axis is this one here. For any point along this axis here, the value of x is going to be 0. So we are essentially saying if I took this formula, made x 0, then the value of y that I would get would be c. So therefore the point 0c represents where this line crosses the y-axis. Okay, and it can be very useful for us to be able to just pick out that information from the equation of the line. Now in order to obviously get it into that format, or to kind of have the equation in that format, we have to do some rearranging. So looking at a question here, convert the equation 2x plus 3y plus 6 equals 0 into the form y equals mx plus c. We can take our equation as it is here. One of the things that we tend to say to do is maybe look at the sign of y. I would like y to be positive, and at the moment it is positive, so I'm probably not going to move it here. I'm going to try and move everything else. Okay, and the way we think about that really depends on you. We're essentially bringing these 2 to the other side, or indeed we could think about that as subtracting 2x and subtracting 6 from both sides. So we get 3y equals minus 2x minus 6, and I can divide by 3 then. Dividing both sides by 3 means I need to divide all of this by 3. So I get minus 2 over 3x and minus 2 on the end here. Okay, now because I've written it in the format that they wanted, y equals mx plus c, I can just look at the kind of the corresponding parts there to see that my slope is minus 2 over 3, and my value for c here is minus 2, which means my y-intercept, the coordinates of that point, are 0, minus 2. Okay, where it's 0 because it's on the y-axis. So you can see how it can be useful to be able to rearrange your equations of the line and to get them into that format, because it provides us with that little bit more information. And again, this is all manipulation of formula, something we would have done in Algebra 2. Okay, so let's just have now a little look maybe at one of the exam questions here to kind of put that into practice. So let's maybe look at this exam question. It says complete the table by matching 4 of the lines to their equations. So what we might want to do here is get those equations into that format that we prefer. So looking at the first one here, it's x plus 2y equals minus 4. I might first of all get the x over to the other side and then rewrite this as a half x minus 2. Okay, so this is my first equation here. So a half y equals a half x minus 2. My second one here, if I bring y over to the other side and the 4, swapping the y and the 4 essentially, 2x plus 4 equals y. So y equals 2x plus 4. Similar here to what we have on the top, 2y equals minus x plus 8, y equals minus a half x plus 4. So I can write that one in. And lastly then, 2x minus 2 equals y. So I've got my 4 equations of lines here. We can look at the different pieces of information that that provides us with. So first of all, I'm kind of noting straight away that I can see 2 of the lines that have kind of corresponding slopes here. Now I'm just double checking that there's no sort of mistakes made here. Let me see. Oh, sorry, I just don't have my minus sign marked in there. Perfect. So I can see straight away that those 2 lines have the same slopes because the number in front of x's is the same for both of them. And even more than just noting that the same, they're both negative. So as they go from left to right, they're actually going down the way. And that's going to correspond with either of these 2 lines, okay, J and L. So I know both of those 2 lines correspond with the first and the third line that I have there. Now we still need to identify exactly which is which. In order to do that, we're going to have to look a little later in the equation and look at these last 2 points here. We've said that that last number is the y-intercept. It tells us where the line crosses the y-axis. So we can see one of the lines crosses the y-axis at plus 4 and one of them crosses it at minus 2. So by maybe looking at my equations here, I might say because this is positive, this to me would be plus 4 and this would be minus 2. If I was to label those coordinates, that's how I would label them. And that helps me then to identify that this must be my line J, and the first one here must be my line L. Now we can do the same thing for the other 2 equations. So again, the slope is 2, so it's going to be these 2 here. And again, I can look at the y-intercept and see, well, this one crosses at 4, so that is m, and the other crosses at minus 2, so that is n. So using all of that information there that we have, so we can see the slope-intercept form, because it gives us that much information kind of easily, it is one that's worth being able to manipulate into, and it's just recognizing when that's going to be useful for you. So we'll look at one last piece of information, or kind of type of information that the equation of a line can give us, and that's when we're verifying points on a line. So we've talked now about the different types of equation, we've talked about the relationship, or kind of understanding what the equation represents, and now we're just kind of pushing that a little bit further to say, well, if I give you certain points, how can you kind of use that relationship? And really, if a point is on the equation, then it should satisfy the equation. So we saw that when we looked at the kind of understanding the equations at the start there, when we were looking through the different points, they were all working with the equation that we'd set up. So to verify these different points, what I could do is take the x value and take the y value and substitute them into each of these formulas or these equations that they're presenting me with here. And what we want to see is for which of the two equations is the point kind of, or which of the two equations does this point satisfy. So we'll work through them kind of simultaneously here. So let's just see. So this is 12 minus 4 minus 7 equals 0. That's 12 minus 11 equals 0, which is 1. And 1 obviously does not equal 0. So that's suggesting to me that the point is not on that line. So let's just see whether it is indeed on the other line. I'm getting 6 minus 6 equals 0. And of course, 0 does equal 0. So that's suggesting then that because my line is satisfied, my point is on that equation. Okay, and it really does just come down to that idea that the point here is satisfying the kind of properties of that equation. So it has the correct slope, there's the correct relationship between the coordinates of the point there, and when I sub it in, I get that 0 equals 0 idea. We can kind of use that then in finding, I suppose, unknowns also. So if they tell me this point is on the line, I'm expecting that it will satisfy the equation. So I could sub it in. So 2 times 2 plus 3 times k minus 7 equals 0. So 4 plus 3k minus 7 equals 0. 3k minus 3 equals 0. 3k equals 3. And we get that k equals 1. We were just asked to find the value of k. We'll write down our coordinate also. Okay, so we can see that there's a lot of information really coming there from the equation of the line, and it is important to be aware of the two different versions or the two different ways that we can write the equation of the line and the reasons why. So in general, we're going to aim for that general form, the kind of longer version equal to 0, but the slope-intercept form is there for us to manipulate into, or indeed go straight to, if we want to have that extra information. And if it's given to us in that format, we're able to pick out the slope. If it's not, we're able to manipulate so that we can work out the slope, or so that we can work out the y-intercept. And I suppose useful for us then in, I suppose, comparing the graphs as we did in the example there, or as we're looking in the next section, maybe finding lines when we're given the equation of one line, maybe finding a line that has a similar characteristic, whether that is maybe parallel or perpendicular or passing through the same intercepts. And kind of all of these things stem from you having that understanding of the equations in the first place.